So this is question 25. You are given a triangle ABC. So we start from A, we construct a point P1. From P1, we get P2, P3, P4, P5, P6, P7, and P8. The interesting part here is that AP1 equals to P1, P2, P2, P3, P4, P5, and so on and so forth until P8A again. If this happens, what is the measurement for the angle PAC? Suppose this is equals to theta, then because these two are the same, so this will be also equals to theta. And if we look at the triangle AP8, P7, these two also the same, and therefore it is also equals to theta. We will focus on this small angle here. For this small angle, it is actually come from here. This is A, P1, P2. Both of them are theta here, and therefore this is equal to 2 theta. Then we do the similar observation. This part from the triangle here also equals to 2 theta. Then we proceed to this triangle. Since P8, P7 and P7, P6 are of the same length, this is 2 theta, therefore this is also 2 theta. P1, P2, P3, 2 theta, this is the same, so this is 2 theta. We do the similar argument again. This is A, P7, and P6. So this is theta, this is 2 theta, and therefore this is 3 theta. Using the triangle A, P3, P2, theta, 2 theta, this will be 3 theta. Again, 3 theta, this will be 3 theta. 3 theta from this triangle, this will be 3 theta. And do the similar argument, this will be equal to 4 theta. This will equal to 4 theta. Finally, the whole thing here will equal to 4 theta, and the whole thing here is equal to 4 theta. The whole thing here is 4 theta because of the triangle P5, P4, and P3. P5, P4, P3. These two are the same, and this is 4 theta, and therefore this is 4 theta as well. Now we look at this triangle only A, P4, and P5, where this is 4 theta, this is 4 theta, and this is theta. Now we can get the conclusion very easy now. The sum of the interior angle of a triangle is equal to 180 degrees. And therefore, 9 theta equals to 180 degrees. Theta will equal to 20 degrees. So 20 is the answer for question 25.